Dear learners, I welcome you all to this online teaching session. Today we will discuss about practical number 8, that is estimation of paracetamol and aceclofenac in given tablet by simultaneous equation method. So aim is to estimate percentage weight by weight of paracetamol and aceclofenac in given tablets using simultaneous equation method by UV spectrophotometry. Requirements, reagents and chemicals. You require standard paracetamol, standard aceclofenac, paracetamol and aceclofenac tablet, methanol. The role of methanol is to dissolve standard as well as sample. So it is a solvent. Apparatus, you require volumetric flask, 50 ml, 100 ml, 10 ml, pipette, beaker and funnel. Miscellaneous requirements are Wattman filter paper, tissue paper. You require UV visible spectrophotometer for analysis and high precision weighing balance for weighing purpose. This is the drug profile, structure of paracetamol aceclofenac, molecular formula, molecular mass, melting point, CAS number, IUPAC name and uses. So preparation of solution, standard solution of paracetamol, weigh 5 milligram dissolve of paracetamol dissolve in 50 ml of methanol to get 100 ppm solution. From this one take 1 ml dilute up to 10 ml to get 10 ppm paracetamol solution. Similarly, aceclofenac solution is prepared. 5 milligram aceclofenac dissolved in 50 ml to get 100 ppm solution. From this solution, take 1 ml, dilute up to 10 ml to get 10 ppm aceclofenac solution. The solvent will be methanol. The tablet to be analyzed containing aceclofenac and paracetamol. 20 tablets are taken. Individual weight is calculated and then average weight is calculated. So average weight of this tablet is 630 milligram, which contains aceclofenac 100 milligram and paracetamol 325 milligram. This is the label claim of your tablet. Now preparation of sample solution, that is tablet solution. So 20 tablet you have to triturate and make a fine powder. So the average weight is 630 milligram. So 100 milligram aceclofenac, for 100 milligram of aceclofenac 630 milligram tablet powder is required. So for 10 milligram, how much tablet powder is required? So X will be 10 into 630 upon 100, that is 630 milligram tablet powder, and that tablet powder you have to dissolve in small quantity of methanol, sonicate it and then make up the volume up to 100 ml with methanol and again sonicate and filter. So you will get the solution where you will have 100 ppm of diclofenac. From above solution, you have to prepare 2 ppm solution with respect to diclofenac. So 0.2 ml of above 100 ppm solution dilute up to 10 ml. So you will get 2 ppm solution. Now this 630 milligram of tablet powder not only contains 10 milligram of aceclofenac, but it will also have some quantity of paracetamol. So we should know कि with that 63 milligram of tablet powder how much paracetamol was there. So 630 milligram tablet powder, that is our label claim, 325 milligram of paracetamol is there. So 630 milligram tablet powder contains how much paracetamol? So y is equal to 325 into 63 upon 630, that comes to 32.5 milligram of paracetamol. So when we were taking 63 milligram of tablet powder and dissolving it in 100 ml of methanol, actually we were also dissolving at that time 32 milligram of paracetamol in 100 ml. So that comes to 325 ppm of paracetamol. So in this 100 ppm aceclofenac solution, 325 ppm of paracetamol was there. Now the solution was diluted from 0.2 to 10. So when this dilution was done, the concentration of paracetamol was 66.5 ppm. So sample solution contains 2 ppm of aceclofenac and 6.5 ppm of paracetamol. So finally we have 3 solutions with us. Aceclofenac standard solution 10 ppm, paracetamol standard solution 10 ppm, and sample solution containing 2 ppm of aceclofenac and 6.5 ppm of paracetamol. Here we have taken aceclofenac as X and paracetamol as Y. So what you have to do? You have to scan these two solutions in UV from 200 to 400 nanometer to get lambda max of aceclofenac and lambda max of paracetamol. So here lambda max of aceclofenac we have denoted it as a lambda 1 and lambda max of paracetamol we have denoted it as lambda 2. Now at these two wavelengths both the solutions are absorbance of both the solutions you have to measure. Means after taking lambda max, that is lambda 1 and lambda 2 for both the component, measure the absorbance of this 10 ppm solution at lambda 1 and lambda 2. Similarly, measure the absorbance of this paracetamol solution at lambda 1 and lambda 2. So you will get 4 absorbances for X and Y at lambda 1 and lambda 2, and absorbance you have to convert it into absorptivity. So you will get AX1, AX2, AY1, AY2. Now sample solution you have to measure absorbance at lambda 1 and lambda 2. So absorbance of sample solution at lambda 1 will be capital A1 and absorbance of your sample solution at lambda 2 will be capital A2. Now we will see how the absorptivity is calculated. So this table depicts the absorbance of X and Y, that is aceclofenac and paracetamol at lambda 1 and lambda 2. What is our lambda 1? Lambda max of aceclofenac, lambda 2, lambda max of paracetamol. Now how the absorptivity is calculated. This capital A1 and A2 are for sample. A1 absorbance of sample at lambda 1, A2 absorbance of sample at lambda 2. Now how the absorptivity is calculated. So A is equal to ABC. Capital A absorbance is equal to ABC. Absorptivity, path length, concentration in gram per 100 ml. So what will be the value of A? A is equal to A by BC. X I have denoted for X1 for X component. So what is the AX1? 0.280. I have calculated for this value. So 0.280 upon 1 is path length into 0.001. Now this aceclofenac solution was 10 ppm. So that 10 ppm you have to convert into gram per 100 ml. So 10 ppm is equal to 0.001 gram per 100 ml, because for calculation of absorptivity the concentration must be expressed in gram per 100 ml. So this value will be 28. So for absorbance 0.280 the absorptivity will be 28. Similarly you can calculate the absorptivity for this value, that is these values. Okay. Now calculation part. So you have the simultaneous equation with you. So if you substitute the values for all these different parameters, you will get Cx and Cy. But Cx and Cy you will get in the unit, the concentration will be gram per 100 ml, because for absorptivity you had calculated you have taken the concentration in gram per 100 ml. So you have to again convert it into ppm, because our theoretical value is in ppm. So what is our theoretical value? Cx, that is aceclofenac, was 2 ppm and Cy, that is paracetamol, was 6.5 ppm. These are the theoretical value in our sample solution. Aceclofenac was 2 ppm, paracetamol was 6.5 ppm. So how will you calculate percentage purity or percentage weight by weight? 2 ppm corresponds to 100%, so 1.9 ppm. This value we have got from this equation. is how much? So it comes to 95%. And similarly, you can calculate for CY. 6.5 ppm paracetamol, 100%. So 5.1 is how much? So that is 78.46%. So result you can express as the given tablet sample contains 78.46% of paracetamol and 95% of aceclofenac. Thank you for patiently listening. Have a good day.